Hi there, and welcome back to our little tutorial series on creating the classic game Pong in Unity with a few nice additions. This is part 2 of the series. If you haven't watched part 1 so far, I highly recommend to check this one out, as we're just gonna continue from the state we left off at the end of part 1. If you're in a hurry though, we got a GitHub repository, the link is in the description, and I also created a tag which reflects exactly the state at the end of the first video, so you can also continue from there. What we got so far is pretty much the basic Pong game logic. We got 2 pedals that we can move with the keyboard. We got a little ball that bounces off the pedals and the walls. And we got a little score counter at the top. What we'll do today is first clean up the project a tiny little bit. Then we'll make the ball faster every time it hits one of the pedals, so to increase the excitement of the game. Then we'll run into some physics problems that we're gonna solve. And we're also gonna add a little dotted line in the center of the playing field. And at the end, for the most complex part of this video, we're gonna change the code for resetting the ball and the pedals. So far, we only reset the ball, and we're gonna learn a bit about singletons and patterns in general and events along the way. One quick note before we dive in. Since last time I upgraded my Unity version from 2020.3.26 to 27, and usually or mostly when you upgrade just such a minor version, nothing bad happens. But things can break if you upgrade your Unity version, and this happened for me when I opened Visual Studio. You don't see this now because I already fixed it, but everything in here turned red and Visual Studio couldn't really find these scripts and assemblies anymore. And the solution was to just right-click somewhere in the project hierarchy and choose Re-import all. Unity then prompts you that this might take a while on bigger projects, but our project is small. It's just gonna take a minute. If you click re-import, it's gonna restart Unity and Visual Studio and re-import all your assets, including your scripts, and then everything will be fine. So let's start with cleaning up our project a tiny bit just. I want to rename this prefab, which is still called North Wall, to Wall, because it's not a north wall prefab, it's a wall prefab. And yeah, it hasn't changed the name in the hierarchy since this is overwritten in the hierarchy already, so everything is good here. And one more thing is in the pedal script, I got this ID as a float, and I want to change this to an integer, to a whole number, because IDs are mostly used as whole numbers, and we're just going to check if they are still correct. Yes, this is still 1 and this is still 2. Perfect. So clean up, already done for now. Next up, let's make our ball a little bit faster every time it hits a pedal, and this is also something quite easy to do. We're just going to go into our ball script and we'll add a new public variable so that we can tweak it in the inspector. And this is the speed multiplier, and we're just gonna multiply the velocity of the ball with this value, and if it's at 1.1, it's gonna be 10% faster on each hit. And where do we hit the pedals? Well, we don't have that yet. To check for this, our onTriggerEnterToD function is not enough, because the pedals are solid objects and not triggers. So we need another function for this, and this is the onCollisionEnterToD function, which is called whenever we hit a pedal or a wall. But in this case, we just want to see if our collision has a pedal component. So we're going to go similar to how we determined the score zone, but this time we cannot just call getComponent, because in this function we only get a collision, and this collision we first have to get the collider, then we can call getComponent and we'll get our pedal. And if we hit a pedal, we are just gonna multiply our velocity with our multiplier, and that's basically it. So back in Unity, let's test this one out. And to test it more easily, I'm just gonna set the max ball angle to 0 so that it only flies around between these pedals and I don't have to use my skills to really show you. So it's subtle at first, but the ball is definitely much faster now. And in a second, we're gonna see a new problem. Okay, there it was. The ball, when it gets fast enough, it just goes right through the pedal. This has something to do with physics, and it's nice because that's the next point on our list, but we're gonna tick the faster ball off for now. This problem with the ball going through the pedals at high speeds is thankfully a really easy fix. We just have to select the ball, and on its rigid body component, we're gonna change the collision detection from discrete to continuous. For moving objects, I always suggest to change this. So let's test it out again and see how fast we can go with this ball. So maybe I should have set the multiplier a bit up, but we got these few seconds right. So I think it's already at the speed it was when it went through the pedals, and it's just gonna go insane now. But it's still not flying through, so yeah, this problem is fixed. The other problem we got, and we already saw this in the first video, is the ball not bouncing off the wall sometimes. We can see this at really low angles. Just like this, it gets stuck to the wall and doesn't bounce off. Once again, the fix is thankfully quite easy. We just have to change one value. We have to go to the project settings, and under physics 2D, there's a value called velocity threshold. And it reads, any collisions with a relative linear velocity below this threshold will be treated as inelastic, which means no bouncing. So we can lower this threshold to say something like 0.01. And by the way, these tooltips are sometimes really helpful. So if you don't understand anything, just hover over it and it's gonna give you a little hint on what this actually does. So we change this and let's test it out again. So yeah, we're at a really low angle here. So if it bounces off with this angle, it's gonna bounce off at any angle. And it does, yeah, it goes down again. So nice. So while developing games, you will constantly run into very specific problems like this that maybe require you to just change some specific value somewhere in Unity. And yeah, for this I recommend just going to the internet and searching for it. There are tons of resources and answers out there, be it just via Google, Unity Answers, the Unity forums, Stack Overflow, and so on and so forth. In 90+% of the cases, you will find your answer quite quickly. So with the physics out of the way, the next point on the list is the dotted line. And I already prepared something for this. We could just do it in what I call a not very elegant way by just having lots of sprite renderers at different positions. But yeah, these are so many objects and we gotta set all their positions to something distinct, and like I said, not very elegant. So let's get rid of it and instead use a Unity component called a line renderer. A line renderer allows us to pretty much just draw a line between different positions. So we got these positions right here. We don't actually use the Z position. So let's make this one maybe 5 and this one -5. And now we see this big pink line appearing. We can adjust its width to something smaller, maybe around here. And yeah, now it's pink and we want it to be white, I guess. And we also want it to be a dotted line. To achieve this, we use something called a material. A material is an asset and determines the way our objects look. I already created a folder for this and also a sprites folder, so to keep everything clean, and we're gonna right click and create a material, and let's call this one dotted line. And now we can assign this material to the line renderer. You scroll down, and down here you see materials, and we're just gonna drag this one in. Let's try changing the color. We go in here, and for a line renderer this is actually a color gradient, and if we change this to red, wait, nothing happens. That's because we don't have the right shader on our material to make this stuff work. The standard shader is more like for lit and 3D environments, and we are going to use the particles standard unlit shader. So the color is not determined by any light, but rather by what we change in here. And now we can see this gradient turning red when we change it. So now let's make it a dotted line, and for this again go into the material, and we are gonna change the texture, and we are going with the default particle. So now we see that it stretches itself very thin, but if we go back into the line renderer and go to texture mode and choose tile, now we got something we can work with. Let's close this off by making a few more changes to the tiling. Let's set, this is counterintuitive, but it's not the Y value of the tiling, but the X value. Let's set it to 2 to have a final line, and let's make it a little more gray. So maybe something like that. Yeah. One more thing maybe, we see in the scene view, we don't see this in the game view as we have a black background, but this line is not rendering in a transparent way. We can change this by going to the material again and changing the rendering mode to transparent. But now we got a new problem. It's rendering on top of the wall, and we don't want that. We could just change the positions of the line, or we could go in here into additional settings and change the layer order down, like -1 is already enough. This order determines how objects are rendered on top of each other, which one is at the front and which one is rendered at the back. So we got the dotted line all done, and all that's left in this video is the final and probably most complex part, and that is resetting the ball and the pedal's position. We already reset the ball's position, and actually we could do a simple solution for resetting the pedals. We could give the ball references to the pedals and just tell them to reset their position every time. But this can get messy quite quickly. Imagine we had more pedals or more elements that should react to the player reaching the score zone and everything resetting. Then we would need way more references, and everything will get messy very quickly. So it would be great if we could have like a central point for resetting the game, and that point just tells every element in the game that is interested in it to reset itself. And thankfully we already got like a central point of our game manager. And to make it do the things we want it to do now, we have to extend it with two a little more advanced concepts. And these concepts are the singleton pattern and events. Events are a way for us to implement something like a publisher-subscriber model. Let me bring up a graphic real quick. So we got one component that is a publisher and that fires or raises an event, and as many subscribers as we want to, and they subscribe to these events, aka listen to them, and each time the publisher decides to fire an event, the subscriber gets notified and can act accordingly. This is pretty much akin to YouTube. If you subscribe to my channel and ring the notification bell, well, every time I post a new video, you get a notification and can choose what to do with it, whether to watch it or not. So to implement the event, we go into our game manager class and add this line, public action on reset. An action is the most simple way, I think, in C# and therefore Unity to use events. And now it tells us that it can't find the namespace action. That's because it's in the system namespace. So we could either use this using directive like we did before, or I just want to show you quickly an alternative. We could just type system.action. So now we gotta raise, aka fire the event somewhere, and the place for this is in on score zone reach. This is exactly the point in time when we want all the elements in the game to reset their position. So we can use this syntax for it. We have to check if this is null, because if it is null, aka no one has subscribed to it, then we're gonna get a null reference exception here. So, but there is a nicer way to write this, and I'm just going to show you real quickly, and it's called the monadic null checking, and this is just this question mark right here, and it's going to do the same thing as before. So this line is the same as these two lines. So now we invoke aka raise, aka fire our event, aka action, but no one's listening yet. Nothing's happening yet. We want our ball and our paddle to listen to this and reset their position whenever this event is fired. Our ball already has a reference to the game manager, and we could just add one to the paddle as well and assign it in the inspector. That's one possibility, but again, imagine our game growing and more objects needing access to this, and then we gotta assign so many references. There's one other alternative, but one I don't particularly like, and this is find object of type, and with this we can try to find the game manager. But this one goes through the whole hierarchy and searches for the game manager, and in big hierarchies with many objects, this can get quite performance intensive. What we are going to do instead is using the singleton pattern. A pattern or design pattern is pretty much just a solution to a common problematic in programming. There are many patterns out there, and some of them are more relevant to game development than others, and some of them are already built into Unity. You see, we have the component pattern here. We can make up an object of many different components and use these components on other objects and just combine them the way we want to. This is the component pattern. And yeah, there are, like I said, many more. I'm gonna leave you a little link down in the description where you can read more about it. So back to our singleton pattern. What does this mean? Right now we have this game manager component, and we could just duplicate this object and have multiple game managers in here. And this is something we do not want, and as an extra, we want the game manager to be accessible from everywhere. To realize this, we're gonna add this line to the game manager. We're gonna create a static instance. What does this mean? Static means that it's the same across all game managers that we could possibly have. Maybe a better example, because we're only gonna have one game manager, would be a paddle. So it doesn't belong to an instance of the paddle, like paddle left or paddle right, like this ID does. We have paddle left has ID 1, paddle right has ID 2. If we were to make this one static, then it would mean it wouldn't belong to paddle left or paddle right, but to all paddles imaginable. It belongs to the type or the class, and they would all have the same ID. This static keyword is something to use with extreme caution, as it doesn't reset, for example, when you reload a scene. If we just restart our scene, all the objects in it are gonna be in the exact same state as they were at the start of the game. But if we start the game and change a static variable and then reload the scene, this static variable will remain changed, and we gotta reset it if we want it to. Maybe it could be the score of the game or something like that. Then we would have to reset it manually in code. So yeah, be careful when using static. Now we gotta actually assign our instance, and we do this in the awake method. And yeah, we just want that to be 1, and we're gonna do it like this. If there is already another instance of the game manager assigned, we're just gonna destroy that one. And if there is none assigned yet, aka the first game manager that comes into existence in our scene, we're gonna set the instance to that one. Let's just test this real quick. We're going to duplicate our game manager a couple of times and start the game, and all except one should be destroyed. Right. So we only have one game manager, and this is the one in our static variable. That was the hard part, I promise you. Now we can reap the rewards. We can go into our ball script and actually get rid of this reference altogether. Now, of course, we get this error. But we don't need this direct reference anymore to the game manager. We can go on the type and the static instance, and now with this we will also have this reference to the instance of the game manager, and everything is going to work just like before. The next thing we have to do is to actually listen for this onReset event, and we do this with this syntax. Again, we get our game manager instance, and to the onReset action we add the listener method reset ball. So every time this onReset action is fired, then we listen and we call this reset ball method. And now it's getting a bit messy here because onReset, right? This is called in the game manager's onScoreZoneReached function, but this one is again called from the ball where we also reset the ball. So let's kick this out of here at first, the reset and the initial push. And this is not a full reset of the ball. Let's call this reset ball position and add a new method called reset ball that resets the ball and gives it its initial push. We gotta exchange this reset ball position, then the initial push. This is our reset ball functionality. And we could call this in the start method, but let's leave it at that for now. Let's go on to the pedals now, and for these, the ball, in comparison to the pedals, it always gets a random start position. But the pedals, I think they should always start in the middle, so we're gonna save this start position. Caution, incoming big block of copy-paste, so I'm gonna walk you through it. So we have a private start position that we save on the start of the game. Then, just like in the ball method, we subscribe to the onReset action, and whenever this one is called, we just set the position back to our saved start position. So let's test out if everything works. We're gonna start the game, and first of all, I'm gonna not press anything. Yes, the ball gets reset just as before, and if we now move the pedals down, they also get reset to the center. Of course, this is your decision if you want to reset the pedals. Like in the original Pong, I think they are not reset to the center, but yeah, for the sake of this learning experience, we implemented it like this. So this last part was a lot to take in, I know, especially for those new to these concepts, but yeah, it was not just for the sake of learning something else, but also I want to get you thinking about your project's growth, and your project will grow, I promise you, if you work on it for longer. And it's gonna get messy, and you steadily have to decide whether we're going with a solution now that is good enough for now, but might need work later, or if we are putting in more time now so that we're more flexible later. And this is actually a really big part of being a game developer, making these decisions. And it's, after all these years, it's still really hard for me. And yeah, I just wanted to get you into this mindset a little bit. So that's it for this video, and we're just gonna tick this last point off the list because it's such a satisfying thing to do. In the next one, we're gonna look at UI and game flow a little bit, making a little start button and windscreen and so on. I hope you're looking forward. I hope you enjoyed this one. If you have any questions or feedback, let me know down in the comments. And I wish you a great rest of the day. See you here again soon, and bye.